I wanted to add this example to the binomial distribution, so with regards to probability, just so that you can have another peek at how to apply and deal with binomial distribution. So here we have a small town, and the probability of finding a person that carries the UY28 virus is 2%. So the probability is independent of the number of people in the town and the interactions between them. Okay, so this would kind of represent the idea of, the binomial distributions with regards to, let's say, finding someone with a virus and then finding someone without a virus. So there's really just two possibilities, right? So we have a 2% probability, okay, of finding someone with carrying that virus. Let's call that, the success, although I guess it's not really successful if you have the virus, but that's how we'll map it. And then we have a 98% chance of not finding someone. So we have three different questions being asked of us. So given 100 random people, find the probability that at least 2 are infected. Okay, so how would we, map this out? So, if we start this example, I'll do it with my, traditional given here. We want to find the probability of at least 2, so at least 2. So this is going to be greater or equal to 2, okay, people with being infected. Now, of course, this would mean that we would have to find out, okay, so what's the probability of 2 plus what's the probability of 3 plus, dot, all the way up to 100, and then add them up and then find out what that would be. Now, the alternative, okay, for this is, of course, saying the following. Well, we can take 100% minus, okay, the probability, okay, of the opposite, which means that we have, less than 2. Now, this is much easier to find because this would just simply be, okay, probability of nobody and probability of 1 person, okay? And then if we subtract it from 100, then we get actually exactly what we are looking for. Okay, so how would we do this, and what would the numbers actually tell us? Well, the probability, okay, of nobody, if you're thinking back, so we have a 100 people altogether. So this one right here, so probability with no one, okay, that would simply mean 0.98. Okay, that's the probability of not having a virus, right? And this would have actually been to the 100 because there's 100 people that we would have. Okay, so that means nobody actually has the virus. So, what is this equal to? And then we would have to add it to, probability of having 1 person, right? Now, having just 1 person, okay, so this is a little tricky. So, if you recall, I can do this by saying, 100 choose 1. Now, why 100 choose 1? Because that 1 person could have been the first person I run into. It could have been the second, third, fourth, and so on, right? So there's 100 different ways, actually. Okay, and I just want to have 1 of them being infected. And this would have been probability, okay, so P, which in our case is 2%. So I'm going to do that. This is just finding 1 person, and then multiply by probability. So this is, let me write it like this, 0.98, and this is 99, right? So this is success, failure, all right? Okay, and that's what we would have. Now, if you've forgotten about the binomial distribution and you want an introduction, I'll also put up a link up above there, okay, if you want it. Now, adding these two up, so what does this equal? Okay, so this is the probability of nobody, probability of 1. So I can add these up, okay, and then find out exactly. So if I swing out the calculator, let's see what this gives me. It's going to be to the 100, so it won't be very big. All right, so this is approximately 0.13, say 26. All right. Okay, so nobody having a virus, so probability is not very high. And then we have, so I'm going to go backwards, 0.98 to the 99. multiplied by 0.02, that's times 1, and then 100 to choose 1, which is just 100. Okay, so this is 0.2707. Okay, I'm rounding it into 4 decimal places for both. So now adding these two up, okay, so 0.1326 plus 0.2707. Okay, so 0.4, okay, so approximately that much. And now we want 100% minus this. Okay, so what would we have? 1 minus 0.4033 equals, so this is approximately 60%. You know, so I'll just round this off. So approximately 60%. All right. So that would have been, you know, with at least, so given 100 random people, find the probability that at least 2, so at least 2 are infected. So at least 2 that are infected, okay, there's about 60% chance of that, okay, which is relatively high actually, choosing those 100 random people. Now, part B says find and graph the binomial distribution for the 100 people. Okay, use Desmos.com to provide a visual graph. I have utilized Desmos actually in that introduction. So if you go back to that link and you watched it, I used it for one of the examples. So I am going to use it in here as well. Okay, so to do this, let me bring out Desmos. So I had it when I was making the other video. So here it is. Okay, I'm kind of going to go back in here and let's see. So what do we have? We have, so first of all, so the probability is 2%. Okay, we have n, actually it's 100 people, so n is 100. So notice I'm just mapping this out onto 100. And then we have our, okay, so function, all right, so f of x equals 2, and choose r. Okay, so notice that I'm doing this. I'm gonna actually swing this over so you can see it, and let's map it out. Okay, and this would be, so it gets high, and it makes sense that it's gonna scatter around, okay, that. And then the rest, the probability is very tiny, right? For any of these, it's practically 0, all right? But it's not exactly 0 because Desmos has rounded it up. So that would have been the nice probability distribution for this. And you can graph it like so. Now, if you chose, let's say 50 people, so we can do that, okay, and we can regraph it. Okay, if the probability, let's say, was much higher, you can regraph that as well. And you can do that within Desmos. It's super efficient in that sense. The last question that they ask us, what is the expected value for this setup? So the expected value in binomial distributions is actually really nice to calculate. Okay, so if you recall, expected value is equal to n multiplied by p. So we have 100 trials because we are taking out 100 people, and our probability is that. All right, and if you multiply this should not surprise you that the expected value, okay, within here, if you do take 100 people, it's going to be about 2%, not, it's going to be 2. Okay, so the number of people, which should be 2 people out of 100 people, the probability is 0.02. That should make sense to you. That would have been the expectation that we would find within 100 people, that many, at least on average, right? It doesn't mean that we're always going to find that, but on average, every time we would sample out 100 people, we pick them at random, our expected value would have been 2 that are actually infected. So this was a great example for probability. It ties into binomial distribution, and Desmos is amazing for graphing these different things. So I do hope that you do get used to it, okay, and you utilize it within. If you have studied my videos on functions in grade 11 and advanced functions in grade 12, you saw that I was using Desmos a lot. I love it as a visual tool, and I think it helps here as well. All right, thanks for watching this video, and we'll hopefully see you in a future one. Bye, everybody.